molecules. We are going to see about such a soil in the okay. Already studied about in the theoretical class. Here we are going to discuss about the property of the materials here. Okay. First, you see that this is the beam test setup. We all know that what is a beam. Beam is nothing but a structural member which supports like support. Okay, maybe roller support, hinge support, fixed support. And here you are having a beam. What type of support is? Can you tell me? This is the cantilever beam. How?
So 196 to 150.
196. Correct. Okay. And one more thing, it is given. It's a channel section beam. Why it's called channel section beam?
So actually,
Sir, in the hollow space.
two channels running.
Actually, it's not type of beam. Okay. It is channel section. Channel means C. Okay. The cross section is C. Okay. That is called channel section. In this C. The cross section will indicate the channel cross section. If it is an angular section. If it is an angular section beam, it is given like this. What do you understand? This is also cross section.
Kind of L shape.
L shape. Angle means L. Okay. The cross section will be a angle. Okay. And what does it mean? Why it is given? Load.
Point load.
Okay. It is point load. Just now we have seen that what is the type of load acting on the beam. First one is the point load. Okay. Because the load applied only at a particular point. Okay, the most area is not covered with a single point. It's a point load. Okay. How can we apply the load now? We have a lever. If you adjust, okay, you load it, what happens?
The load will
You apply the load. What direction?
vertical direction, downward.
Downward direction. Okay, it's called this is the lateral direction. Then the horizontal direction will be called longitude. It is along the axis of length. If it is perpendicular to the axis of length, it's called lateral. Okay. So if you apply the load, okay, then the load will be applied on the material. So how much load you are applying like this? Accordingly, the deflection will be there. And why this kind of beam test section is given? Why this load? Because if you apply the load, there will be deformation. Some amount of deformation will be there, but you cannot view it how much it is. For that, we have to use which instrument we are going to use to get the deflection. Any guess?
Beam test setup.
One more thing. Anything else? There is a called a vernier dial gauge. Okay, vernier dial gauge. Vernier dial gauge means if you apply the load, approximately it will be given in the opposite direction. So it will come down, and the probe of the vernier dial gauge will go. It will be pushed. So accordingly, the vernier dial gauge will rotate and it will indicate. One full rotation will give you 1 centimeter. Okay, 1 centimeter of. Like that, we are going to do the experiment. One more thing. What type of material can you see this? What type of material it is?
Aluminium.
Aluminium. Okay. If it is fixed brass, the same test you are going to do, you are applying the load. Okay. If you apply the instead of aluminium, if you apply the brass material, what do you infer?
Brass is more stronger than aluminum.
Then the deflection will be
Less.
If you get steel,
It will be steel is more durable than compared to aluminium and brass, so the deflection will be relatively very low.
okay, what parameter, okay, what is the technical parameter will indicate to get this kind of deflection is very low or high? You are telling it is stronger than this one. Okay, whether it is hardness or
Applying more load.
So
which technical parameter?
change in length by load.
Can you guess from the Hooke's law? What does it tell? Stress by strain. You just complete. Stress by strain equal to Young's modulus. Generally, stress is directly proportional to strain within the elastic limit. We are going to put this equal to by removing the directly proportional. So we are going to introduce a new constant. That constant must be a material constant. That is the Young's modulus. So Young's modulus will give you the terminology to give more amount of the resistance to more amount of deformation. Okay, if the Young's modulus is higher, okay, it will give more strength. So that the bending strength, actually it is called bending strength. So if it is applied the load, it will bend. Okay, so the bending strength is more for steel and then brass and then aluminum. Okay, the Young's modulus, you have to get the significance of Young's modulus. So if Young's modulus is higher, the bending strength is more. If it is lesser, less amount of bending strength. Okay, like that. So that's a type of flow. Now, anyone tell me, for a uniform, it is a point load. I want to get a uniformly distributed load. Instead of this load, what would be given? What kind of material will be given for a uniformly distributed load?
Flat plate.
Flat plate.
More surface area.
More surface area with
With the flat
surface. Okay, because it is uniformly distributed. Unevenly it should not be. Arbitrary points like a brick you can take, no? Brick type of. Okay, it is uniform, rectangular section glass. Okay, you just apply here. So uniformly it will be applied from the entire stack. It is called a uniformly distributed load. Likewise, instead of brick you can take a right angle triangle. That kind of load you can apply. That is called a uniformly varying. Okay, so that is the concept we have studied. Here also, same how the beam is going to get the deformation as well as bending strength as well as bending moment. Also, you can find based on the type of load acting on the beam. Okay. Let's do the experiment. Then we will find out the deformation. Okay, this is the general basic concept what we have learned in the class. Okay, so that's how we can do it in the next class on that topic. Okay, thank you.